in those 2 beakers of water is room temperature water. Okay? Then we have blue food coloring that is hot. Is it hot?
Very hot.
It's actually pretty hot, okay? I couldn't hold my finger in the water very long. It was hot. And we have ice cold blue food coloring. It's cold. Icy cold. There it is. It's just floating in its icy water. Okay?
So
now, go ahead.
So we're going to be looking today at the effects of temperature on ocean currents. So the food coloring is representing water, right? It's just colored water. And we're going to see what the different temperatures will do in an ocean current.
Yes. Oh, exciting. All right. So today in your journal, you should have a section. You know what? Maybe I should just make this little journal page form real quick. You need in your journal a section for cold. Are we doing cold or hot first?
Cold. Let's
cold.
do cold.
Let's do
first.
cold first. So
It's really fun.
yeah, we're pretty excited. Can you tell? So I'm going to share this screen with you. I let Bailey Jordan in. Did you mark her down? Mm-hmm. Awesome. Okay, so I'm going to share the screen with you, and we're going to pretend this is my journal. Click to add title. Let's see. Today I said this would be investigation 5.1, day 3. And here, in your main section, you're going to have cold water. Let's see, cold water observations. Okay, and then, oh, you don't even know about this part yet. Cold water wind observations. What, Miss D? It's true. And then you're going to have hot water observations. And you guessed it, hot water wind observations. Okay, so get your journal to look like that, please. I'll give you, oh, I'm not good at being patient, as we know, so I will give you a little bit of time.
Okay, so leave yours on. I'm going to take hers for a minute.
Okay.
Because I think somebody wanted it. Yes, Andrew.
You see the value of being here on time? Like if you're late, man, you're going to get in here and just be behind. Whew. Maybe 45 more seconds to let you get ready. If you're at home, here's what we want your journal to look like.
I let somebody in named David.
Oh, it's probably Webb.
Okay.
Okay, so if you're at home, make your journal look like this.
Maybe I'll fix that.
Whew, it is so tough to be patient. Into the cold water, into the room temperature water, we're going to add cold blue water. And your job, guys, is to write down what you observe. Remember, what you observe would be with your 5 senses. Turns out today you get your eyes.
Here we go.
1, 2, 3, 4, 5, 6, 7,
Oh gosh.
8,
Need a little more.
9, 10. Ooh.
Ooh, what's happening?
I'm going to put this camera here and see if you guys can see. Oh yeah, you can see. Okay, so write down your observations. Oh, I wish I could get you I got to get you a little closer without wiggling it. .
Oh,
Yeah, is that a
maybe
little better?
that's better.
Like that's a little better. Yeah, that looks a little better. If you can't see it very good, you can pin that to the big screen so you can see it better.
Hey, does everybody have their observations about the cold water? Just give a thumbs up, those that we can see.
Awesome. Now we're gonna add wind.
Wind.
And so the way we add wind is we use a bent straw so that we can get the air to blow across the water, not down into the water. So we'll use the bendy part to direct our air, not into the water, but across the water. Let's
So
try
it's
it.
kind of backwards. Okay, here we go. Adding wind.
I'm observing.
Ooh.
I'm looking, I wonder if it'll like swirl or move around down below or up top. I feel like we need darker food coloring. What do you guys, can somebody unmute and tell me what you see?
Nothing is happening.
Oh, you're seeing nothing?
The blue is just staying in one spot. Yeah, it's staying in one spot.
So are you saying that staying in one spot as the whole beaker is one spot, or down below, or up top?
Down below.
Down below it doesn't seem
It's
to be
kind of
moving.
starting to mix.
Oh, okay. I think I would agree with you. So I would say, from what I observed, is that any blue that was up top moved around when we added air. But the blue that was at the bottom didn't move as fast. It took a while, but towards the end, it kind of started to move. Okay, make your observations in your journal, and then we'll be back. Can we add some blue? Because it was tough. Beaker of water, of room temperature water, so same temperature as the other one before, and we moved it closer to the camera. Now we've added some food coloring to the hot dropper, so hopefully it's easier to see what happens, okay? And now we're gonna put 10 drops of hot blue water into the regular water and observe what happens.
Wait for it.
Ooh, let's count.
Here we go.
1, 2, 3, 4, I think, 5, 6, 7, 8, 9, 10. What? That's not doing what the other stuff did. What's going on here?
Stay at the top.
Oh,
It
good
is staying at the
observation.
top. What?
It's staying up the top now.
I agree.
Write that down.
Yes,
Write that down.
write that down. Good, good, good. David Webb, you were a little late. We are doing investigation 5.1, day 3 in our journal. You might want to just write this on paper and add it to your journal later, because I think it'll take you a while to get your journal open. We're making observations, bud.
Are you ready for wind?
Yeah, let's add the wind.
Here we go.
What? Owens, are you seeing this?
Yeah. It's going to go all over the place.
Guys, I feel like that is very different from what happened just a second ago. Make your observations in your journal. What happened when we added wind? That was a good one, Mrs. Dennis.
Whoop.
Can I have my black marker and I'll fix the hot sign? Be a little more legible. Oh, that works. Oh, put this in here. Okay, does anybody want to share something they wrote? That was so exciting.
Nobody's brave?
Holden, talk to me, girl.
For the hot and wind observation, I said when they added the wind to the blue water and the hot water, it started mixing with the regular water right away, unlike the cold.
Awesome. That is great. Does anybody know why it seemed that the wind mixed up the hot so much better than the cold? Mr. Hefner?
Because it's not frozen. Since it's hot, it's not frozen, so it can mix better.
I think you're onto something. Owens, were you going to add something to that?
The cold water is like cold air, it sucks stuff in, and the hot water is like the hot air that pushes stuff out, which is what kept the dye on the surface until you mixed it up. And the dye in the cold water was pulled down because the water was cold.
Thank you, Mr. Cox. I didn't call on you, but I'm glad that you responded. Mr. Owens, did you have something to add because you had your hand up a moment ago?
Because I remember yesterday saying how when it gets close to the equator it goes faster. I think that it does that because you said like the hot water gets it all warmed up and energetic.
Yes.
The molecules.
Holden, do you have something to add?
Because the molecules in the hot water are moving faster than the molecules in the cold water.
Yay! I love your terminology.
Yes, molecules! Mr. Webb, you have your hand up? Maybe it was an inadvertent hand up.